first part is we're looking for a crossover of the MA indicator. Let me see, just make sure I got that correct. Yeah, the MA indicator. So we get a little crossover here. So that's that's the entry point. But the question is about the exit point. So so we're looking for, hopefully you guys can see this little triangle area here. And what's being looked for is when the white line, let's see, so that's I believe the white line is the MA. The blue line is the FAMA. And so when the white line begins to slope in the opposite direction of the trade, right? So we have a down crossover, so a down crossover for a short trade. And so then if the white moving average begins to slope up for 2 bars, so we're looking for 2 bars of a opposite sloping MA line here. So that's the key to the question here that's being asked, is how do we generate an exit signal when we get 2 bars of a moving average sloping up like that, right? So that's the crutch of the question there. All right, so that's the first question we got to start us off with. All right, so let me pull up a chart. We'll get started with this first question here. So let's see, let's take a quick look at the markets here. So yeah, we're just kind of riding along the support line here, and listening to the news and everything. It looks like we're ready for the markets to fall back down to some previous support lines down here. At least that's what kind of sounds like. I mean, if you listen to the news, things are kind of scary out there, but we'll see where it goes. All right, so let's see. We got a chart here, and let's see. This is a tick chart. So let's see. I've got oil on here. Let's see. So I'll just pull up a 200 tick chart. There we go. All right, so I need to get the MA indicator on here. And all right. And let's get the colors adjusted. All right, so let's find, here we go. We have a cross up. Here we have a cross up. And so this would be a pretty short-lived trade. Because it looks like we have 2 bars. Yeah, we have, let's see. Just looking at the screenshot here. All right, yeah, so we have 2 bars of the white moving average sloping down, right? 2 bars of the white moving average sloping against the direction of the trade. So basically after this cross up, our exit would be on this bar right here. So this would be the bar that would fire off the exit signal. All right, so again, the key to this question is finding these, finding 2 bars in a row where the moving average, the white moving average in this case, would be sloping in the opposite direction of the trade. So, all right. So let's get BloodHound open and start building. So let's put today's date in there. All right, it's lucky number 7. All right, so I'm going to just start working on the logic board here right away. So I'm going to go to the logic tab and I'm going to create a new logic template there. So this is going to be, this is an exit signal. Let's see, exit. Trying to come up with another name here. Let's see, exit. So 2. All right, 2 bars. Actually, exit would be it'd be a 2 bar slope. Let's see. Yeah, so I guess we're looking for a 2 bar slope in the opposite direction there. All right. All right, so first thing we're going to grab here is a slope solver. Let's just connect that right up. And let's see. Let me open this up here. All right, so we're looking at the slope of the MA moving average here. And sometimes I like to name the solvers, you know, if they're being used for an exit, kind of like to just, sometimes I'll preface the name of the solver with just the word exit, just so I know that this solver is specifically being used for an exit. You know, because when I come over to the solver list, you know, usually when you're building something, you'll have a bunch of solvers used to generate the entry signal, right? That's very typical. But then also if you start building an exit signal logic template, then yeah, sometimes I like to put, you know, the word exit in the name of the solver. That way I know that that solver is being used in the exit logic versus the entry signal logic. So, all right, so let's swap out our indicator here. I'm going to replace the SMA with the MA. There we go. And just using default settings here. And let's see, the white line is the default plot. So that's already selected for us. So that's good to go. All right, so we can see on the chart here that, yeah, I was correct. Right here, our little triangle. Here it's marking when the white moving average is starting to slope down, right? So we're getting a, so BloodHound is giving us a short output, or I should say the slope solver is giving us a short output, right, when the moving average is sloping down. And naturally, if the moving average is sloping up, then we're getting a long output, right, the green from the slope solver. All right, so now we, instead of getting, right, so right now we got 4 bars with a short output, but we only want the short output on the second bar there, right? We want to wait for the second bar. So how do we do that? Well, we're going to grab a look back node. So there we go. Grab a look back node. And we want to turn the displacement off, set that to 0. And we want to look back for 2 bars. So we're going to put a look back period of 2 in there. And then the look back mode will open up and become available. And we want a minimum of 2 bars with the downslope. So we're going to use the minimum. Right? We use the minimum mode there. So now let's take a look at that look back. And there we go. So there, that would be our exit signal. Now, typically, the fact that we have, 2 other bars marked with an exit signal, typically that's not going to be a problem because this is an exit signal, right? So you can't. So once the first bar with the exit signal, once it fires off, right, it's going to flatten your trade, and so the other exit signals, well, there's nothing to exit anymore, so they'll do nothing essentially. And also the way this system works is, when you get a trade, there's definitely not going to be an exit signal because, right, the same moving average that is used for the exit signal is also used for the entry, right? So in this case, our exit signals would not interfere with the entry signals. So we could just leave it just like this, and this should work fine as an exit signal. So let's take a look back. Yeah, here we go. So here is the entry, right? So there's our cross down for the entry, and we can see the white moving average is sloping down, sloping down, sloping down, and right there would be our first exit signal for this short trade. So, and yeah, again, leaving these other exit signals, wouldn't do any harm in this particular, system, or it wouldn't do any harm with this particular entry signal. So, however, if you do want to clean it up, if you'd like to clean that up, that would be pretty easy to do. We could just grab a signal blocker. Connect that signal blocker up, and I'm just going to guess we probably need to block for 50 bars. I'm just going to take a little guess here. I could shrink my chart up and just kind of look. We have a fairly long stretch of exit signals, and that's probably not quite 50 bars yet. I'll scan through the chart here and see if there's any really long stretches of this exit signal. And yeah, here's another long stretch, but I'm going to guess that's less than 50 bars. So I'll start off with 50 bars, and let's go back here. All right, so I'm going to block signals for 50 bars. And then the next step is I'm going to go through the resets here. So I'm going to just turn them all off. And our reset is going to be the input no signal. So what that is right. So what we're seeing the signal going to the input, right? So this look back node, right? We're looking at what's coming out of the look back node, and this look back node is connected to the input, right? So of the signal blocker, right, we're connected to the input. So when there's no signal, right, so that would be this bar right here. This bar here where there's no no signal anymore on the input. So when we get these blank bars with no signal, right, those are the bars that we want to reset the signal blocker, right? Or we want to turn the signal blocker off. Oh, Frank, you want your microphone enabled. Oh, okay. Okay, sorry. I misunderstood. I thought I thought Frank couldn't hear me. There you go, Frank. So Frank, you're going to have to enable the microphone on your end. There we go.
Hi, Zach.
Howdy, Frank. All right. If you could just speak up a little bit. Good, good.
Okay,
How are you doing?
I'm good. What I probably wasn't very clear in my write-up, but on the exit signal, I wanted to not get the signal only on the first output, but the second. In other words, a more extensive slope on the second. So in other words, if we were to look at option output 2 and output 3, so the second bar would be an output 3 signal. In other words, it would require a slight change in the slope and a greater change in the slope on the second bar.
Gotcha. All right. Yeah. So you actually want to use the change in slope solver.
Yeah, I think I put that in the I think I put that in the write-up there that the second bar was to be there was to be an increase in the slope, and the other thing is and it was probably be a little bit more clear in my second letter, is that I wanted to find out how I can somehow control the intensity of the slope, or how much the slope is changing.
Yeah. All right. Yeah. That option is not available in the slope solver. It's just looking for any minute additional increase in the slope. Yeah. There's no slope adjustment with the change in slope solver.
There's no granularity check.
Yeah. Only the slope solver has that option. And yeah, so if you're looking for a change in slope, let's see. Yeah, there's the slope solver. Yeah, wouldn't help with that. Yeah.
Yeah, I think.
Right.
Did I say slope? I probably meant to change the slope instead of the slope solver.
All right. Yeah. So, yeah, and quite often I find people are using the change in slope when really they want the slope solver. So
Yeah.
I find that's a common mistake. So I would have just assumed you literally meant the slope solver there. Okay.
Yeah, I meant to change the slope. Sorry.
Good. Thanks for the clarification. So, all right. So we're going to switch over to the change in slope here. And so let me plug the indicator in. And I will re-explain to everybody else here what's going on here. So we got all right, there's the MAMA. The default plot is selected for us. All right, so we'll set this one aside and let's give this a name here. All right, just shorten the name of this solver up a little bit. Okay. All right. So the change in slope, for anybody who's not familiar with this solver, what it's looking for, let's see. I'm just going to give a quick explanation. There's a much more thorough video to watch for the change in slope here, but just to give a brief explanation, I'm going to need a graphical image here to help explain what this is doing. So, right, so I'm on the documentation page here. So under the BloodHound reference, we're going to go to the confidence solvers, and then there's an indicator change in slope. So that's the solver that we're using. And if we scroll down, there's an image right here. Let's open this up. So what the change in slope is looking for is it has various outputs. And they're numbered 1, 2, 3, 4, 5, and 6. So actually, let's make sense of this. So, all right, so if we're looking at the change in slope, so you see all these various outputs, and they're numbered 1 through 6. Right? So you can get output, you can get an output from the solver from any of these areas. So these numbers refer to areas here. And so this image helps illustrate what area of slope is being referred to. So number 1 and number 6, right? That would be this output and this output. So if the moving average is sloping up, so we can see that the plot here is curving up, and it's it's curving up in a increasing rate of rise, right? So the moving average is constantly increasing its slope until it's basically straight up and down, right? So that would be output 1 for the long side. So output number 1 would give you a long output. That's why the number 1 is green. And to get a short output, so you see the red number 1 here. So this solver would give you a short output. Let me set all these 0 first. All right, let's blank those all out. That way they're less distracting. So in this number 1 output, right, you would get, this solver would give you a short output, right, where the red number 1 is. So if the moving average is now sloping down and it's constantly increasing its rate of fall, then that would give you a short output from the solver, right? So kind of the neat thing about the change in slope solver is how the outputs can change from 1 to 2 to 3. So if we look at the green number 1, right? So the number 1 output will be outputting as long as the moving average is increasing its rate of rise. But if the moving average ever begins to, it's decreasing its rate, right? So obviously this moving average, so the black line, right, it's still rising, but it's not increasing its rate of rise. So it's rising, but it's kind of decreasing until it rolls over and starts falling. So that's what number 2 is that, well, the moving average is rising, but its slope is decreasing as it's rising. And number 3, right, the number 3 output, where the number 3 bullet is here, it would be a second bar where the plot is still rising, but the plot it's decreasing its rise for a second time in a row, right? So you have 1, 2, and 3. So they'll give you a long output at various stages of a moving average, rising, right? So, or it'll give you a short output. So you can see the number 1, number 2, and number 3. It'll give you a short output at the various stages of how at various stages of the rate at which a moving average is falling or sloping down. So what Frank is interested in is he's interested in the number 1 area. So he's looking for a second bar where the slope of that MAMA, where the slope of the MAMA is continuing to increase in its rise, right? But if the moving average, the moving average could still be rising, but it's not increasing its slope, right? So the moving average is rising, but the slope is not increasing in its rate of rise. So if the moving average falls into the number 2 and number 3 zones here, then that disqualifies the exit signal. The exit signal, we have to get 2 bars in a row that fall into zone 1, where the moving average is continuing to increase its rate of rise, or the moving average will continue to increase its rate of fall. So let's go to the chart and let's actually find an illustration here. So let's see. Well, we have one right here. So right here on this bar. Right, so again, let's back up, look at the bigger picture. So we have a short signal there. So we're kind of in this short trade. And so we're looking for right, the white moving average to slope up, but we need 2 bars in a row where the angle of the moving average needs to keep angling up, right? So the moving average needs to keep increasing in its rate of needs to keep increasing in its rate of rise here. And we can see right here, so here's our first bar where the moving average basically changes direction. So that's zone 1. But the second bar here, it's pretty easy to see that even though the moving average is sloping up, but it decreased its angle, right? The angle decreased. So therefore, we didn't get a long output here. Now here, it's a little less obvious, but the moving average did increase its rate of rise, and it's continuing to increase its rate of rise on the second bar as well. So actually, these two angles could be exact, these 2 bars could be the exact same angle, and that would give us this long output. So to really see this, sometimes you really have to stretch your chart out a lot, right? So I'm really going to exaggerate this chart, and so now we can really see. So obviously, right, the moving average is sloping up, and then we can see that the moving average really flattens out here, but it's still increasing, it's still rising, but not as much. And let me change the Z order on this. There we go. So now we can see the white line on top of the bars. So we can see that, yeah, the moving average really kind of flattened out, even though it's still rising, but it flattened out, so therefore no output. And then we can see on the next bar here, the moving average its angle got steeper moving up. And on the next bar, this area, again, the angle got a little steeper and rising up. So this second bar where the moving average is rising and it's increasing its angle in its rise is what Frank is looking for as his exit condition there. All right. So All right, so what we're looking for is, again, we're looking for two bars in a row of the, of the angle of the moving average to keep increasing, right? So basically, this here wouldn't qualify as an exit signal because this second bar here, the moving average began to kind of flatten out, so that disqualifies it for the exit signal. So we're looking for this condition over here. So we can just take our change in slope solver and plug that into our look back. There. And so if we look at, so let's take a look at the look back now, like so. Okay, so there's kind of our unfiltered slope solvers. Yeah, and let's see. I'm kind of wondering if we even need really the signal blocker. So, right, again, this is our long. This is the long entry condition, and we only got one bar with an exit signal, right? And the rest of these are what exit shorts, but this is not a short. This is not a short trade. This is a long trade. So all of these green exits just get ignored. So we don't need to clean those up. Yeah. So I would say all we really need is just this look back node, like so. That's really all it's needed. But if you wanted to paint a pretty picture, we could use this signal blocker still, and and we'd still need to get the resets set up here. So I think, let's see.
Zach, can I interrupt a second?
Sure.
The second bar should be greatly turning. In other words, the first bar is in direction but turning, and the second bar should indicate a greatly turning condition.
Let's see. So that would be number 3 here,
Yeah.
where this.
Bar number 1 would be 2, and bar number 2 would be a 3 condition.
A 3. So you do want the moving average to start rolling over.
Yes.
Oh, okay. All right. So let's re-explain this, folks. All right. So let's stretch the chart out here. And
I guess what I'm trying to do is figure out some way where I can increase the granularity of the slope, so that I don't get a lot of false exits on a very slight slope.
All right. So just to clarify, so the first bar we're looking for, well, basically just the initial reversal,
Right.
slope in the wrong direction, and then you want to look for it to flatten out.
Okay, looking. So
this is number 2 and number 3. So when it flattens out, it's still rising, but it's flattening out. That's output number 2 and number 3.
Yeah, if you were to go to the one where the boxes where the dotted bar key is around the 2 bars that are, that second bar, that would be the condition where it's greatly turning.
No, this is if we look at the solver, the only output I have turned on is number 1. So number 2 and number 3 are turned off. So we can't. So we're not seeing number 2 and number 3. We're only seeing state number 1. So let's go back to our image. So we're only seeing state number 1 where the
Yeah. Okay.
rise of the moving average is continuing to increase. Yeah, probably what the most difficult part for people to kind of grasp in this image is that state number 2 and number 3, the moving average is still rising, but it's flattening out. It's beginning to flatten out until it rolls over. Yeah. So, okay, so just to be clear, you do want the moving average to flatten out on the second bar, or you want the moving average to keep increasing in its slope, to keep the slope, the angle of the slope needs to keep rising, keep increasing.
Yes.
Okay.
Keep, in that case, rising.
All right. Yeah. So where the red diamond is, that would be the correct bar.
Yeah.
Yeah. So if I really stretch this out, sometimes you really have to stretch this out. There, we can see. So we got an increase in the slope, or in the angle. We got an increase in the angle, and then we got a second increase in the angle. And so that's what you're looking for. Is 2 increases in the angle in a row. Okay.
Yes.
All right. Yeah. So that is what we have here. So if I take a look at the look back, there we go. We have a signal right there on the red diamond. Yeah. So that is it. So.
Oh, okay.
And if we look at, let's see.
I'm finding that I just don't seem to be able to get the level of sensitivity to the slope that it's giving me more exits than what I would like based upon the slope, especially with the mama, because the mama is not a very smooth curve.
Okay, so
like some of your moving averages are a lot smoother. This is a very choppy type of indicator.
Yeah. So let me explain this my way here and see if this is what you're looking for. So again,
I think my second example would show you. It shows you like which signals I would like to be able to recognize and which ones I would like to be able to ignore.
Okay, yeah. Let me take a quick look at that email here. There we go, part 2. All right, so we want to kind of ignore the flatter kind of change reverses. All right, yeah. So we can apply like a what's a good explanation? A flat kind of. We can apply a global slope angle requirement to this by using the slope solver. Right. So the slope solver will give us, we can apply a minimum slope requirement to that. So
I interrupt you there. One of the things that that in looking at this, and I was curious about it, is that using ticks when you have a different number of ticks depending upon the instrument.
Mm-hmm.
So for example, if you were to trade the ES, you have 4 ticks to a point. That gives you, a 25%. I was wondering, versus something else where there's 10 ticks to a point. So the significance of a ticks, I'm not quite sure is a good measurement of the slope. And I was wondering in there someplace if it could be based, and I know it's not there now, but if it could be based upon a percentage of change.
Essentially, the simple answer is no. We've thought about that, but that gets really complicated. yeah, it gets really complicated in trying to figure out what your base angle is, that you're getting a change in angle from. So yeah, so we never figured out a good way to implement that. But the closest we can get right now is with ATRs, right? ATRs will adjust with volatility, kind of get you in that ballpark. It's not exactly the mathematical formula that you're looking for, but yeah, looking at an ATR, I think might work for you, right? ATRs in general work across multiple instruments, right? An ATR is kind of a right. It's the simple solution of generalizing things across multiple instruments that have different tick sizes.
But the ATRs are non-directional.
Right. Well, I mean, so is the slope. The slope applies to both directions. So yeah, there is no like long slope requirement versus a short slope requirement. So, yeah. So, I'm just kind of throwing that out there. If you play around with the ATR, you might find a solution using the ATR so that it works.
I haven't tried the ATR, but it seemed to me, just looking at it, and I don't know again the implementation, but it seemed to me that a percentage would kind of normalize it across instruments.
Yeah, agreed.
A percentage check.
Yeah, and if we can find a good way to implement that, we will. But yeah, we haven't found a good way to implement that yet. So,
okay, all right.
So, all right. So, just for the sake of this, let's just go with ticks, and I'm going to try 0.1 tick at first. Here. All right. So we're going to use a slope solver, and so what we're trying to do here, folks, is we're trying to eliminate. So when the MA indicator, right, when it changes direction against the trade, we want to eliminate these kind of flat, angled, slopes of the moving average, right, when it's flat. We're looking for these really strong increases in slope as the exit point here. So let's go back to the chart, and we'll explain this here.
Just for your information on that, I did change the indicator. That's why it's a channel.
Yeah, I saw.
Okay.
Yeah,
Okay.
no problem. All right. Let's see. So we want to. All right. Yeah. So looking at the chart. Okay. So let me back up. So we're looking at the slope solver again here. All right. And I have a minimum slope of 0.1 ticks. 0.1 ticks. And so what that has done is, you can see here, when the moving average is really flat, right, there's no output from the slope solver. So, right, so you can use the slope solver to identify flat, kind of flattish sloping moving averages here. So let's see. Let's see how well. All right, so let's apply that over here. So if you guys remember, this was the first area that we were looking at for our exit signal here. And so let's just say that we're going to consider this as too flat of an angle for the moving average. So we want to disqualify. We want to disqualify this as an exit signal because the angle, right, is a little too flat. So what I'm going to do is I'm going to take the, hold on, let me adjust things a little bit here. All right. So what we're going to do is we're going to adjust the slope amount until this short output disappears here. So let's try 0.15 and see if that works. And that works. Okay, 0.15. So not much of a difference. All right, so basically we can see that the slope solver now has no output in this area, you know, so that would disqualify this as a exit signal. So we have the first component built, which is looking for, right, looking for the angle of the white moving average to, you know, to keep increasing its angle for the exit signal. Here, I'm just going to get rid of the signal blocker there. Let's get that out of the way. So, yeah, so we can see. So we do have, so when this white moving average, when it changes, when it starts sloping down, it is, the angle of that slope down is increasing in a downward angle, right? The angle is increasing down. So therefore, our change in slope solver, you know, is identifying that the angle of the downward slope is increasing. So that half of the requirement is met, but we have a slope solver that would be the second half of the requirement, and it does not have an output. So if I take both of these and join them together with a AND node.
AND node, yeah, okay.
Like that. So now this AND node actually becomes the actual final exit signal of both conditions combined together. So all right, so let's just gonna take a look at things here and take a look at the chart. All right, here we go. All right, so there's our entry, and we're in a long trade all the way up until this point here. So, and we can see that we can see right here that our moving average begins to slope down, right? So we definitely have a pivot point right there where the moving average is sloping down. So let's zoom in there. Let's stretch that out. Yeah. And so what we can see is that for these first couple of bars, the angle wasn't enough of an angle. There wasn't enough of an angle, right? It was a little too flat, even though it's sloping down, but it's a little too flat, and so therefore it didn't trigger the exit signal, right? So it waited until we got a steep enough angle over here, right? So once our moving average got a steep enough angle, then that allowed the exit signal to occur. So.
Okay, which one was the one that controlled it? Was the min or the max? You had them both the same, so
yeah, the way you're using it, you want to keep them both the same. So the min and max is a part of the fuzzy logic. So Again, so the outputs of the slope solver, right? You can see there's 4 different outputs for the slope solver.
Right.
Right. So you can see the bottom 2 use the min, right? See how in parentheses it says min. So that would use the min slope. The upper 2 in parentheses it says max and max. That would use the max slope. So yeah, so this just having two slope values gives you fine control if you're using fuzzy logic within BloodHound. But you're not using fuzzy logic, so just keep both of them the same.
Gotcha. Okay.
Yeah. All right. Yeah. So that. Go ahead.
Yeah, I was gonna say, I guess if you couple that with a bar direction, you could get even more granular then. Where the 2 bars would have to be in the same direction.
Correct. Yes. So, right. For example, because we got a. So this is an exit signal on an up bar, right?
Yeah.
Yep. So that would eliminate an exit signal on an up bar. Right.
Yeah, it might move it over to the next one where the green is now or something. Okay,
So,
I understand.
actually, no, it would not. We only got 1 bar here with an exit.
Yeah, well, it'd be further over, yeah.
Let's see, that's an up bar and that's an up bar. All the exits are occurring on an up bar. Oh, here we go. We finally have one on a down bar. So if I plug this bar direction in, yeah, there we go. They all kind of disappear, except that. Yeah, except this one way over there. Yeah. So, yeah. All right. We'll just leave that disconnected for now. So, all right, and let's go let me clean up all these drawing tools here. So let's go take a look. Here we go. All right, so here was our other exit point. So again, so that was our entry short. And so if we zoom in here, if we take a look at this, right, so right there is where the MAMA begins to slope in the wrong direction, in the opposite direction, but it's a little too flat. And yeah, it's just basically, it is just a little too flat here. So, so the exit signal waits until we get this nice steep angle right there. All right. So, Frank, does that cover all of your questions?
Yes, I think it does. Thank you.
Okay, great. So this question is about solvers and logic templates. So right on the solver tab, we have a list of your solvers here. And in the logic template, right, that's where you actually see the solvers. Now, the reason why we have a solver tab is so that you can see a master list of your solvers. Now, any of these solvers here, they can be used in multiple logic templates. So let's go back to the logic templates here. Right, so far I have just one logic template. Now, if I create a new one, so now I have 2 logic templates, right? Two different ones. So I'll switch to this new logic template. Now so you can see I have a list of existing nodes. So I can put this slope solver on this logic template. Now this slope solver, on the new logic template, that's the same slope solver as this one on this other logic template, right? This solver and this solver, they are the exact same solver. They are both this solver right here on the solvers tab, right? So this one solver is being used in two different places, in two different logic templates, right? So, so if I change the settings in one, it changes all of them because they're all the same solver here. So let me take this 15, and how about if I just put a 9 on the end there? I'll put a 9 on the end, right? So I changed the maximum slope to 159. So now if I go to my logic templates, if I look at this solver, we can see its slope was changed to 159. And if I go to my other logic template, and here's that slope solver again, it was changed to 159, right? And that's because in all three of those locations, they're all the exact same solver. So if you need to use like the same solver in two different logic templates, yeah, so you need the same solver in two different logic templates, but you need to change some of these values, then you need to make a copy of it, right? So so let me see here. So if I go back, so let's say I want this one to stay at 1.5 or 15, right? So I edit this one back to 15, and then if I go back to my other logic template and I take a look at this solver, and it's like, oh, it's back to 15, but I want this one to be 159. So what I need to do is I'll get rid of this one, and I'll go to my solvers tab. So there's the solver I want, and on one of the logic templates I want it to be 115, but on the second logic template I want it to be 159. So what I need to do is I need to make a copy of it, right? So I can call this exit MAM, and I'll call it something like number 2, right? So I know the difference here, right? So I have like the original, and then I have a number 2. And actually here, there we go. So they both have a similar name, but I put a number 2 on one of them so I can tell the difference between the two. So on this number 2, this one, I can change that one to be 159 on my slope, right? And then I'll go to my logic board here, and so what I want to do is, instead of using the original exit MAMA slope, I'll use the number 2, right? The copy I made of it. Plug that in. So now I can have a different slope requirement in a different logic template. There. All right. So let's see. Is Jack in here? Yes, Jack is in here. Great, great. So there you go, Jack. So that's what's happening there. So that was his last question here. And all right. Well, with that, guys, I think we got it. I think we wrapped this one up. So hey, everybody. All right, go enjoy the weekend. TGIF. So you guys have a good week, good weekend, and I hope to see you guys next week. All right, thanks, guys. Talk to you later. Bye-bye.